So, one of the hard things in this topic is writing formulae. The thing is, we have to be able to write formulae to pass this achievement standard when we're going to assess it. You've got a couple of weeks to learn how to do this. So that's why I'm going to video this, so you can actually watch this video again over and over until you get good at it. So because we're doing this as the assessment tasks as a portfolio, if you're no good at writing formulae when we do the assessment, just wait, do it the next time we do an assessment, or the time after, or the time after that. And at the very end of this unit, you're going to be given a sort of like a tidy up day, where you get given a whole lesson just to finish off things you didn't complete in your portfolio under exam conditions. So this video is so that you can learn it at your pace. All right? Now, when we write a word equation, which we've now got very good at, we end up often seeing that a precipitate is formed, and another chemical which is dissolved in the water because it's more attracted to the water than to each other. We need to be able to write the formula of the precipitate particularly, but also the other chemical. So how do we do this? Well, the first thing we did when we looked at our reactions is we wrote the names of the chemicals that were reacted together. So for example, one that we've done a lot is copper sulfate. And we're getting in the habit of putting the cation or positive ion on the top, and the anion or the negative ion on the bottom, plus sodium hydroxide. So the first thing we're going to do is we're going to do our word equation, because that makes life a little bit easier. Then we have an arrow to say what's being made. Now, could anyone help me write the first product, the first thing that's made? Anyone confident enough to have a go? Or at least its first name. Go.
Wouldn't the first one be copper hydroxide?
Perfect. So the first one, in case it didn't come on the video, was copper hydroxide. Now the way that was done is we took the first name of the first one and the second name of the second one to make this chemical. Now we also know, because we've done this experiment, that copper hydroxide is a precipitate. So we often are asked to circle the precipitate. So we might as well circle that now. It's not the only thing that's made though. Something else is made. And that's with the two words that are left over. And we keep the top one at the top, the bottom one at the bottom, so the name reads properly. So sodium sulfate. Right, now, another nice thing is when we did this reaction, we found some things written on the bottles. We had the names written on the bottles, and then there were all these symbols. And if we copied them carefully, this one was Cu, then it had a bracket, OH, and keeping the capitals and the small letters the same, then another bracket, then a little 2 down the bottom. We'll copy the plus down here, so it's a bit like maths. You keep the pluses and the arrows, which are the same as equals, underneath each other. Sorry, I put the wrong one there. I put hydroxide. Gone ahead. This one was SO4. Please just put a line through that one on your paper. I've jumped ahead. I've given the product. We had copper sulfate, and we had sodium hydroxide, big N, little a, big O, big H. And those are written on the bottle, so I don't have to do any work. They are written there. I don't have to do any work with that. I just have to copy them off the bottle. So when you're doing an assessment task, make sure you do that. Make sure you copy the symbols that are on the bottle, please. Okay? Because you're not going to get any marks for these, but they might help you do this side. Okay? Now, here's where it gets tricky. Here's where we need to work out the formula of things. And this is why we've had to start learning our ions. So we go through our memory bank, or our list in front of us that we're given for the assessment, and we look for copper. What is the copper ion? What is it? Cu, and what charge does it have? 2 plus. So we've got Cu 2 plus. What about hydroxide? What's hydroxide? OH, and what's its charge? Negative. Now, for a compound, which is what these things are called, they're called a compound. For a compound to exist, the charges have to balance out. How many pluses have I got? 2. So this is where your maths, your algebra is really important. This is like saying Cu plus plus. So it's sometimes an easier way to write it. Rather than the 2, write out that many pluses. How many minuses have I got? 1. But I need to have 2 of them. I'm not allowed to put another minus there. So how could I have another minus over this side? I actually gave it before with the answer accidentally.
After the minus 1, you put times 2.
Times 2, and the times 2 has to be for the whole thing. So I write OH minus down again. Now I've got 2 pluses and 2 minuses. Anyone not see the 2 pluses and 2 minuses? This cancels out. So 2 pluses and 2 minuses means we have no charge overall. This is excellent. Now I've got to work out how to write it. And I wrote it up before accidentally. So what we have is copper, hydroxide, hydroxide. Yep, so copper, hydroxide, hydroxide. The way we write it is we put the Cu, oops, wrong colour. We put the Cu, and then before someone said we need 2, which is very good. We're going to show that there's 2 of those. And see that little 4 there? That little 4 means there's 4 oxygens. So you put numbers after things to say that there's multiples of them. That means there's 4 oxygens. Well, I need 2 hydroxides, the whole thing. So to keep it together, so I've done the hard one first actually, to keep it together, we put it in brackets. Again, a bit like algebra. Keep things together by putting them in brackets. How many did I say we need? 2. So I write a little 2 down here. Okay. Notice that the charges have vanished. That's because there's 2 pluses and 2 minuses. They cancel out. I don't need the charges anymore. Alright, now I've done the hard one first. Let's have a look at the other one, sodium sulfate. What's the charge of sodium on our table of ions? Who can remember that one? It starts with Na, so sodium's Na, so we're still learning this. Plus, well done. And what about sulfate, the SO4 thing? What's that one? Have a little look. SO4 has a 2 minus charge. So rather than writing 2 minus, I'm going to write minus minus. Because that's 2 minuses, isn't it? Are they balanced? Do they cancel out yet? What do I need? Another plus. But I can't just put a plus there, so what do?
Put another one, another Na plus.
Fantastic. A whole Na plus has to be put in there. Now how many sodiums do I have? 2. So, I've written my Na. How do I show that it's 2 of them?
2.
Where do I put it? In front or at the end?
Put a 2 down at the back of it.
So down there?
Yeah.
Perfect. Then what do I write after that? Yes? Say it louder. Brilliant. SO4. Right. This would help me get achieved because I've got the products, the formula of the products correct. Now they're not always that hard. If I have a look at these two, you'll see why they haven't got any little numbers or brackets or anything. They're really easy. Okay, and if I have a look at it, copper is 2 pluses. And what's sulfate? It's on there. 2 minuses. Do they already cancel out? Yeah, 2 pluses, 2 minuses. Think about it as your left hand and your right hand. If they match up, oh yep, they're gone. Right, whereas when it was 2 and 1, oh, I need another one. Alright? So, you just need one of each of them for the pluses and the minuses to cancel out. What about sodium hydroxide? What's the charge of sodium? Just plus. And what's the charge of hydroxide? Just minus. So they cancel out and make a chemical called NaOH. So they just stick together. It's a bit like the bits, the male and the female bits that were of the Lego. Okay, the sticky up bits in the holes. They all have to match up. There can't be anything left over. All right. So what we're going to do today is I'm going to write up the names of a whole lot of chemicals. What you're going to do is use your table of ions to try to write down their formula. All right. So we're going to start really easy and we're going to get them harder and harder and harder. Any questions?